Sometimes trying to squash the myths and canards of climate deniers seems a bit frustrating. For every one you swat, 10 more crop up. For instance, I still get emails from people convinced that ice in the Arctic is recovering and growing. In this video, I'm going to let the scientists speak for themselves.
The polar ice caps have been shrinking in summer and expanding in winter for millions of years. But in the last 3 decades, the Arctic sea ice at the end of each summer's melt has been getting steadily smaller. The decline was already alarming, but in 2007, when the sea ice melt shattered the previous record by almost 25%, researchers at NASA's Goddard Space Flight Center wondered, is this an anomaly or part of an even more alarming trend? In March 2008, the ice cap rebounded to a near normal winter level. But much of this ice was thin, single-year ice, and after a record rate of melting in the month of August, the ice shrank to its second smallest extent on record.
The American Meteorological Society has a series of online lectures from climate experts for those interested in hearing real information. One of the leading experts on Arctic ice, Mark Serez, a longtime researcher and now director at the National Snow and Ice Data Center, presented in this series in November of 2007.
But overall, what's happened is the Arctic has simply shown a general warming, in large part, and the sea ice cover is responding to that. One of the ways it's responding is that the age of the ice is becoming younger. The ice is becoming younger and younger and younger, and therefore it's actually becoming thinner. It's becoming thinner and thinner through the years. So let's think if you started out with spring, before the melt season in the Arctic, with rather thin ice. Well, it doesn't take as much energy to melt out the thin ice than it does the thick ice. So that means large areas of the ice pack then become vulnerable to melting out in summer. And we're starting to see that process. My colleague James Mislanik at the University of Colorado has put together an animation of the age of ice that illustrates that, shown here. This loop is running through the years, in this case 1987, 1988, 89. Areas in the red is where the oldest and thickest ice is found. So you just look at those areas of reds and the yellows. Going through the years, we're losing more and more of that thick old ice. 2004, 2005, 2006, and there's 2007. Now we're running through the loop again, but you can just see that through the years, just look at that area of red, how we keep losing so much of that ice. That's one of the keys to understanding this loss, this tendency for the ice to becoming younger and thinner through the years, a pattern that seems to be continuing.
But what about more recently? What's happened to the ice since 2007? A quick Google search leads to the latest NASA satellite data from the fall of 2008. In these NASA animations, the lightest color represents the thickest ice. Over the last several years, the area of the thickest ice has continued to decline, showing that NASA data confirms that 2008 represented the lowest total volume of sea ice in the satellite record. The condition of Arctic ice is important because the critical function it plays in regulating global temperature. As sea ice declines, more open water is exposed, which absorbs more heat, both from the sun and directly from the air. More heat equals less ice equals more heat equals less ice. It's a self-perpetuating feedback effect, one of many that science continues to discover.
As the ice melts, less light energy is reflected back into space, and more of the sun's energy is absorbed into the ocean, which fuels further melting.
Melting permafrost is yet another critical feedback as the Arctic warms.
We are at a lake that's down by Denali, and parts of the lake have a lot of methane, and parts of the lake don't have very much methane. So we want to understand where that methane is coming from. Permafrost is thawing. It's actually warming up and thawing beneath the lakes. And that process feeds bacteria that make methane. So when we look across the map, and we look across the Arctic, we see all the millions of lakes, we recognize that those lakes are all emitting methane.
I'm going up this inlet here, where I think I found a methane hotspot. It looks like the ice has been kept open by a high rate of methane bubbling. You can see the bubbles kind of coming up and popping at the surface.
As we see the temperature increases that are projected for the future, that means that the places in the Arctic that are frozen, the permafrost environment, warms and it thaws. And today, there is as much carbon in the permafrost as there is in the atmosphere. So if all the permafrost warms and thaws, and all of that carbon is converted to greenhouse gases, it would double the amount of CO2 in the atmosphere. But in fact, much of the permafrost thaws beneath lakes, and we estimate that the amount of methane that can come out of lakes is 10 times the amount of methane that's right now in the atmosphere.
In this clip, Dr. Walters guides geologist Ian Stewart on a Siberian lake where the methane feedback is ongoing. The surrounding permafrost shows the effects of greenhouse warming, slumping and collapsing into the lake bottom where bacteria begin to convert the organic matter to methane, a greenhouse gas 20 times as powerful as CO2. The gas is bubbling up in such quantities that it actually bursts into flame when released. The process is happening at millions of sites across the Arctic. Dr. Stephen Chu is a rare bird among political appointees. The new Secretary of Energy is a Nobel Prize-winning physicist who recently discussed the permafrost feedback in an interview.
There is a reasonable probability that once this starts, the amount of greenhouse gases released could then be larger than, it can even dwarf the amount of greenhouse gases that humans are putting in the air now. And at that point, it's completely out of our control, in the sense that even if the humans stopped emitting more greenhouse gases, the release of the trapped carbon material in the tundra just runs away. We don't know exactly what temperature this is going to occur, but as we go to warmer and warmer temperatures, 4, 5, 6 degrees centigrade, many scientists are feeling that this may really kick in. We cannot go there.
Some people like to play up that the uncertainties are so large we really don't know what's happening, when in fact scientists know with a great deal of certainty that the Earth is warming, that humans are causing that warming, and that the warming will continue, and there'll be a lot of associated changes in the future. There'll be changes in precipitation, for example, increased aridity. The uncertainty with respect to what's already happened is very small. We know the Earth is warming, we know people are causing it. The bigger uncertainties are how that'll play out in the future. But we've looked at a lot of those issues, I think all of them. Some of them raised like that this is just part of a natural cycle, or it's caused by the sun becoming warmer. These are things the scientific community started looking at decades ago and really got our arms around about 10 years ago for most of them. And we've been able to discount them as possible drivers of what's been going on in the Earth system over the last 100, 150 years. What we're seeing, especially in the last 50 years, is a dominance of human activity in the Earth's climate system, a dominance over natural processes. This is not a natural cycle. This is not the change in the sun. The sun's been flat in terms of its irradiance over the last 30 years. And people are still claiming that it's causing the warming. It's just impossible.
Dr. Overpeck and all the others are among the overwhelming majority of working scientists who every day are shooting down the humbugs and shibboleths of climate denial. The scientists are winning, and this is their story. Keep coming back to this channel where I'll continue to bring you the best information, real science from real scientists, here on Climate Denial Crock of the Week.